Welcome to The Explainer. Today, we're getting into something that's honestly a total game changer for IT support, QA, and devs, Charles Proxy. Because let's face it, we've all been there, right? Staring at some totally useless generic error message, relying on vague user reports. It's the worst. So in this explainer, we're going to see exactly how to intercept and tweak network traffic to fix things with actual precision.
To really get why Charles is so vital, just picture this scenario. A user drops a ticket in your queue and literally all it says is, login failed. That's it. You pull up the app and the UI gives you absolutely zero clues. No error codes, no stack trace, just a generic little pop-up. From a support side, we're flying entirely blind here. Is the server rejecting it? Did it even reach the server? Without seeing the network layer, finding the root cause is just a super frustrating guessing game.
Okay, let's dive into this. Just look at the difference here. On the left, you've got your standard HTTPS traffic. Now, obviously, it's encrypted by default. That's fantastic for user privacy, but man, it is terrible for debugging, because it basically just looks like scrambled garbage to us. Without a proxy, we literally can't see what the app is sending or what the server is sending back. But check out the right side. That decrypted JSON payload, that clear, structured data, that is the exact visibility we absolutely need to actually fix things.
So that brings us to Charles Proxy itself. Basically, it's a web debugging proxy that acts as a man in the middle. So instead of your Mac's browser or mobile app talking directly to some remote server out there on the internet, it talks to Charles. And then Charles talks to the server for you. Sitting right there in the middle allows us to capture, inspect, and even dynamically change all that HTTP and HTTPS traffic on the fly. It's literally like having X-ray vision for your network. All right, let's get this set up on macOS so you can see it in action. The initial install is incredibly straightforward. You just download Charles from their site, and the very first time you open it, your Mac is going to ask to grant proxy settings permission. You definitely want to say yes to this. By doing that, Charles automatically configures your system proxy in the background, meaning it'll seamlessly route your traffic through itself without you having to go dig through advanced network preferences.
But just routing the traffic isn't quite enough. To actually read that encrypted HTTPS traffic as plain text, we have to do a little bit of macOS security gymnastics. You'll go up to the Help menu and hit Install Charles Root Certificate, which pops open your keychain access. Now, here's the crucial part that trips so many people up. You have to actually search for that Charles cert, double-click it, expand the trust section, and explicitly tell your Mac to always trust it. If you skip this step, the SSL handshake fails, and your browser will just block everything.
Now, I do need to pause for a pretty serious warning here. Never install this on a production machine, and definitely don't use it to intercept traffic on websites you don't own. When you set that root cert to always trust, you are actively allowing Charles to act as a man in the middle and decrypt secure data. Now that's perfectly safe and totally essential for your own local debugging, but it fundamentally bypasses the security of HTTPS. So just keep this tool strictly contained to your testing environments, okay?
Okay, moving on. Since decrypting literally everything running on your machine gets super noisy, Charles makes you specifically opt in the domains you actually want to inspect. You just head to the proxy menu, open SSL proxying settings, and add your target. For our little support scenario here, we're using a public REST API sandbox, recrest.in, on port 443, which is the standard HTTPS port. Adding this specific rule keeps our workspace laser-focused on the exact API we care about, so we're not drowning in the background noise of like Spotify or Slack running on your Mac.
And this brilliantly illustrates the real wow moment of using Charles. Look at the left side. Before we configured that SSL proxying, the intercepted traffic literally just shows up as unknown or binary garbage. You can't read a single thing. But on the right, once SSL proxying is enabled and our cert is trusted, boom, the encryption falls away. We can read the clear JSON text natively right inside Charles. Suddenly, the app's behavior is a completely open book.
So now that we can actually read the traffic, we can transition from just passively watching the network to actively controlling it. And that is exactly where breakpoints come in. Just like debugging code, a network breakpoint pauses a request or response right mid-flight. When something trips your breakpoint, a window pops up, and you can manually inspect the raw data, tweak the headers, or even rewrite the JSON payload on the fly right before you hit execute to let it finish its journey. But if you find yourself manually pausing and editing the exact same thing over and over, you're going to want to use the rewrite tool instead. Rewrite is basically the automated, hands-off version of breakpoints. You just set up rules to automatically modify headers, swap out status codes, alter response bodies, or even fake server errors on any live traffic that matches your filters. It is an incredibly powerful way to test how an app handles weird edge cases, all without touching a single line of backend code.
All right, let's bring this all back to that mystery login failed ticket from the beginning. We fired up Charles, triggered the login in the app, and caught the server's live response mid-flight. So the crucial point is right here on the status line. The server is throwing an HTTP 401 unauthorized code. Because of this, we know for a fact the network is totally fine and the request actually made it to the server, but the server actively rejected it. But we can dig even deeper than just the status code. Now, what's really interesting about this slide is the raw API response body that Charles decrypted for us. Take a look at that JSON payload. Error, invalid credentials. So the root cause isn't a server crash, and it isn't some weird networking bug. The user just typed in a bad password, and the front-end app completely failed to pass that actual helpful error message to the UI. Mystery solved with hard evidence, not guesswork. As we wrap things up, I want to leave you with one specific number to keep in the back of your mind: 8888. That's the default local port Charles Proxy listens on to do all this magic. Just think about the diagnostic journey we went on here. We started out completely blind to a really vague error, but by routing through port 8888 and setting up those certs, we got total visibility and turned a frustrating guessing game into a really precise, evidence-based process. Which brings us to one final question. Are you ready to stop guessing and start actually inspecting your own app's traffic? Charles Proxy really empowers you to stop being a passive observer and start mastering your network layer. I highly recommend grabbing the trial, setting up those root certs on your Mac, and seeing exactly what your apps are really whispering under the hood. Thanks for tuning into this explainer, and hey, happy debugging!